Bismillahirrahmanirrahim. Today we are going to speak about the inverse trigonometric functions. So we have to focus on this term, inverse of trigonometric functions. For the inverse functions, and we have discussed before, we have some conditions to find inverse function. And for a function to have an inverse, it must be one-to-one function. One-to-one function means for each value of y, there will be only one value of x, or for any value in the codomain, we will have only one pre-image. And to check whether the function is one-to-one or not, we are using something called the horizontal line test. If the horizontal line test intersects the graph in more than 1 point, then it is not one-to-one. So this graph is a graph of the function y equal to sine x. Now y equal to sine x is not one-to-one function. For example, if for y equal to 0, we have x equal to 0, x equal to 1 by, x equal to 2 by, or minus by, or minus 2 by. All of these will give me y equal to 0. So it is not one-to-one function. But I need to find the inverse for the sine function. So to find the inverse for this function, we have to make it one-to-one function. So we have to do some restrictions on the domain of the function. I will not use it from minus infinity to plus infinity. So I'm going to use small portion of the domain. So to make it one-to-one function, y equal to sine x. Now to make it one-to-one, we are going to use this part of the domain of the sine function from minus pi over 2 to pi over 2. Now on this interval, when x equal to between minus pi over 2 to pi over 2, the sine function is one-to-one on this interval, minus pi over 2 to pi over 2. So this is one-to-one function. The horizontal line will intersect the graph in only one point. So y equal to sine x with this restriction minus pi over 2 and pi over 2, the function is one-to-one, so we can find the inverse for the sine function. And the inverse function is defined to be y equal to sine inverse if and only if x equal to sine y. Y equal to sine inverse. This notation means inverse. It is not power. It is not sine to power minus 1. This is notation to say this is the inverse function, sine inverse. So y equal to sine inverse x if and only if x equal to sine y, where x will be between minus 1 to 1 and y is between minus pi over 2 to pi over 2. So we can say. Now for the original function sine x, for this one, we have the domain is equal to minus pi over 2 to pi over 2. And the range is equal to minus 1 to 1. This is for the sine function. For the sine inverse, the domain will be the range and the range will be the domain. And we can say, now the sine inverse, or this sine, will be in the first quadrant and fourth quadrant. Based on this restriction, x between minus pi over 2 less than or equal to x less than or equal to pi over 2 means that the sine will be in the first quadrant and the fourth quadrant. But it must be between minus pi over 2 to pi over 2. We are not using coterminal angles now, or greater than 90. So the value for x will be in this interval. Now if we speak about the inverse function, y equal to sine inverse x, you can see now y is the output equal to sine inverse x, and x will be between minus 1 to 1, so the domain in this function is equal to minus 1 to 1. This is the domain, and the range minus pi over 2 to pi over 2. So we can say in general, the output of the inverse trigonometric function is the angle. We are looking for the angle when you are given the exact value for the trigonometric function. What will be the angle of that value or corresponding to that value? And the graph of this one will be this shape. So this is the graph of the sine inverse, y equal to sine inverse x, where x must be between minus 1 and 1. This is x between minus 1 and 1. And y between minus pi over 2 and pi over 2. This is the range, and this is the domain. Let's have some examples. Number 1, let's find the angle. Number 1, sine inverse of 1/2. Now, sine inverse of 1/2. We can think about this one as what is the angle theta, or y equal to, not y this case. Let's say theta equal to sine, or 1/2 equal to sine theta equal to 1/2. Now, which angle? That's its sine equal to 1/2. This is the meaning of this question. You are given 1/2, and we have to find the pre-image for that one. This is theta, and this is the value. This will give me sine. The reverse, start from the value to find the theta. That will be sine inverse. So if you are given 1/2, what will be theta? So we can think about this theta. Which angle its sine equal to 1/2? So I can say theta is positive either in the first quadrant and second quadrant. This is positive number. So it will be either in the first quadrant or second, but for the sine inverse, we don't have second quadrant, we have only the first quadrant and the fourth quadrant. So the theta will be in the first quadrant because this 1/2 is positive. We are looking for the angle. What is the angle? We have to keep in our minds, we are looking for the angle. If we are given the inverse function or inverse trigonometric function, we are looking for the angle. Now, sine inverse equal to 1/2. It is 1/2 in the first quadrant, theta equal to 30. So sine inverse of 1/2 is equal to 30 degree, or it is pi over 6 radian. Let's have another example. Number 2. Sine inverse of square root of 2 divided by 2. Again, we are looking for the angle. Now, sine by square root of 2 divided by 2, this is positive. So we are looking for angle in the first quadrant. This must be in the first quadrant. So we are looking for angle for which sine theta equals square root of 2 divided by 2. And there is only one angle in the first quadrant whose sine equal to square root of 2 divided by 2, and that is equal to 45. So sine inverse of square root of 2 divided by 2 equal to 45 degrees. or I can write it in radian, which is pi over 4 radian. Let's have one more. Number 3, sine inverse of minus square root of 3 divided by 2. Now this value is negative, and sine is negative either in the third quadrant or fourth quadrant. But sine inverse is not defined in the third quadrant. So we are looking for in the fourth quadrant, or it should be negative angle, because we know that sine inverse is between. The output will be the range is between, again, minus pi over 2 to pi over 2. Since this is negative, so it will be in the negative part of the range. Now sine inverse of minus square root of 3 divided by 2, if we just ignore the negative, we know it is, but it is 60. This is one of the special angles. But since this is negative, I will have minus 60 or minus pi over 3. So sine inverse of minus square root of 3 divided by 2 equal to negative 60 or minus 60 degrees, or it is minus pi over 3 radian. One more, number 4. Sine inverse of minus square root of 2 divided by 2. This will give me a negative angle, and we know it is sine of square root of 2 of, so sine inverse of square root of 2 divided by 2 equal to 45, and since we have negative sign, this will be minus 45, which is equal to also minus pi over 4 radian. So this is how to find the sine inverse. We are looking for the angle of this one. So just put it as a remark. If you are given theta, we need to find value. We are using sine. The reverse, if you are given the value and we need to find theta, we use sine inverse. From theta to the value to sine, from the value to the angle theta, we have to use the sine inverse.